Okay, so here we go. The first thing I want us to do is we're going to graph an exponential. It's wonderful. All right, so y is equal to x stop. Y is equal to 2 to the x, okay? Y is equal to 2 to the x. What's that called? What type of function is this? An exponential. It has an x in the exponent. It's an exponential. All right, so we can graph it, right? What's his domain? All real numbers, negative infinity to positive infinity. What's his range? 0 to positive infinity. Very good. So I'm just going to pop some points up here and graph it really quick. We know that it is approaching 0 down here, okay? Now, what about when it gets right here? When x is 0, what's 2 to the 0 power? 1. So this point on there, which is 0, 1, is a point. What about 1? What about when x is 1? What's 2 to the first? Okay, so at 1 it's 2. At 2 it's 4. Okay, and then my graph looks like this. Alright, what's this asymptote? Now, it's a line. Y equals 0. Okay, y equals 0. So here is his asymptote. What's his domain again? What's his range? 0 exclusive to positive infinity. Very good. All right, so let's talk about the logarithmic equation. Now, what did I tell you about? What's the relationship between logs and exponentials? A logarithm is an exponent, but what's the relationship between logarithmic equations and exponentials? They are blank of each other. Not opposite. What? Inverses of each other. They are inverses of each other. And y'all, inverse functions reflect across what? Y equals 0. X. Y equals x. The y equals x line. Okay? So I'm going to draw that line right here. Now really, if you want to find an inverse, what do you do? How do you find an inverse of a function? Switch the x's and the y's and you solve for y. Okay? I don't know what you're talking about, so hang on just a second. Okay, so let's switch the x's and the y's. Alright? If I switch the x's and the y's, this is going to say x is equal to 2 to the y. Do you agree with that? Okay, so let's write this. Let's write this as a log. Alright, yesterday we wrote logarithms as exponentials, so let's see if you can write this. Let's see if you can go the other way and write an exponential as a logarithm. Alright, so obviously it's going to be log base what? 2 of what? X. Very good, the answer. So log base 2 of x, and what is it equal to? Y, because a logarithm is an exponent, so that's my exponent. Alright, so now I want to know what this graph looks like. Well, I know it's the inverse of this function right here. So essentially all it's doing is taking all these points and what? Yeah, swapping them. You're switching the x's and the y's. So this point over here, instead of being 0, 1, he's going to be 1, 0. And this point right here, instead of being 1, 2, he's going to be what? This point right here, 2, 1. Okay? In this point right here, instead of being 4, 2, he's going to be 2, 4. Oh, he is 2, 4. Sorry, I flipped it myself. I'm sorry. 4, 2. Okay? Now, what is his asymptote going to be? This one is y equals 0. He's going to be, this one right here is y equals 0. This one's going to be x equals 0. You got to switch those x's and y's, people. Okay? So this is what his asymptote looks like. Instead of a horizontal line, it's a vertical line. I'm not going to tell you right now. So this is what it looks like. This is the log function graph. What is his domain? Yeah, look, guys. His domain is his range because you switch the x's and the y's. 0 to infinity. What's his range? Perfect. Okay? So, a beautiful picture. Inverse functions. Graphically, what they look like. Points. See? 1, 0. 2, 1. 4, 2. Asymptotes, domains and ranges, all that stuff. It's all flipped.
So
all right.
Doing that, like it flips the domain and range. So
Mm-hmm.
like that's like every single one.
Yeah, because they're inverses of each other, and that's what an inverse does. It switches the x's and the y's. Okay? All right, so let's graph one of them. All right, I'll draw me another graph. Come on, wake up, people, wake up. You're gonna think that. Alright, so we're going to graph y is equal to log base 3 of x. Okay? I'm going to show you how I graph it. Do I know generally what that equation is going to look like? Yeah. You see? I just graphed one over here. Okay? It's going to look something like this. Now, I can do all kinds of transformations on it. Right? I can move it left, right, up, and down, make vertical stretches, vertical compressions. I can do reflections over the x, reflections over the y. I can do all kinds of stuff to it, and I know what happens. This one, I changed the base, okay, but it still should be similar to that. So here's what I do, all right? I rewrite this thing as an exponent, okay? If I rewrite it as an exponent, then what's my base? What's my exponent? And what's it equal to? Okay, so what's weird about this is instead of like we usually pick the x's and find the y's, what am I going to do now? Yeah, I'm going to pick the y's and find the x's. Okay? So I'm just going to pick some points for y. I'm going to pick -2, -1, 0, 1, and 2. Alright, so let's pick -2. That will be x to the -2 power, right? Come on, you're almost there. Come on. Alright. Whoops. Sorry. So 3 to the -2. Y'all, that's 1 over 3 squared. Remember that? Okay, that's algebra 1. So that's 1/9. Everybody agree? I don't go and graph them now because I can't, because once I flip them, what do I want to go over here and graph? -2, 1/9, and that's not what you're supposed to be graphing. So I'll find them all first, and then I'll go and graph them, okay? -1, that's 3 to the -1. 1 over 3 is just 1/3. 0, 3 to the 0 power, what's anything to the 0 power? 1. 1, what's 3 to the first? 2, what's 3 to the second? 9. Okay, so now I'm going to go over here and I'm going to graph it. Okay? So the first one I'm going to graph is 1/9 negative 2. So at 1/9, it's negative 2. Ever so close to 0. At 1/3, it's negative 1. At 1, it's what? 0. At 3, it's 1, 4, 5, 6, 7, 8. At 9, it's 2. So, connect the dots. Now, is this a good graph? It's not, y'all. If you drew that, now let me ask you this question. If I could put it in my calculator, would this be what it looked like? Yes, it would. Okay? So you have to be careful. You got to understand what the functions look like, because your calculator is going to tell you it looks like this. But if you don't know that that thing really goes like this, okay, and this is my asymptote, all right, then you'll get point counts taken off. All right, what if I did this? Y is equal to log base 3 of x plus 2. What's that going to do to it? Move it to the left 2. That's all it's going to do. What's my asymptote now going to be? X equals negative 2. Okay? And this little point right here is going to go 1, 2 to the left. Okay? Yeah, it's all just a translation. This little point right here is going to go 2 to the left. And then you can draw your graph. Yes?
So they would just, like, when you divide obviously more on our paper, but then you just need to plot these ones down.
Well, I was just showing a translation, so it's okay when you're doing that, because, I mean, I can see all the other points. But when you're graphing it, yeah, I want to see some more points than that when you're graphing. Okay? All right, so everybody got graphing. Everybody okay on that? Okay, so let's go back and work some logarithms. Now, what I just did was, in Chapter 2, I just skipped examples 1 and 2 and 3, and went and did the graphing, got it out of the way, and now we're just going to be working problems. Okay? So, we are in 3.2, and we are going to do example 1A. All right? Are you ready? This should be stuff you already know. So, we kind of did some of these yesterday. So, no, you'll be okay. If you weren't here yesterday, you should be okay. All right, so, yeah, after a few, you'll get it. Log base 2 of 32 is equal to, don't say it out loud, just kind of keep it in your head. Some of you still need to rewrite it because you're just not quite there yet, but you'll get there. After you work a few, you'll start to get there. Okay? So, a lot of you, if you don't know how to do logs, we always start off teaching you how to write this as an exponential, right? So there's my base, 2. A logarithm is an exponent, so I'm asking you, what power do I raise 2 to get this answer, 32? So 2 to the what power is 32? Very good. So my answer is 5. All right? Here's, do what? You just have to know, y'all, you should know 2 to the 5th is 32. Okay? That's just something you should know. It pops up a lot. Okay? So, B, 4. So, what about this one? Log base 3 of 1. Log base 3 of 1. Here's what it's asking you guys. It's saying 3 to what power is equal to 1? What is it? Perfect. Good job. Alright, here's the next one. This is C. Log base 4 of 2. Log base 4 of 2. Okay, so here's what it's asking. Here's what it wants to know. 2 to the what power is equal to, sorry. I was trying to make my pen, hoping it would work. 4 to the what power is equal to 2? Obviously, this power is less than 1, okay? What do I do to 4 to get a 2? Square root, okay? Square root. So, the square root of 4 is 2. Where do roots go? In the denominator. So, this is 1/2. 4 to the 1/2 power is 2. Roots go on the bottom, powers go on the top. Okay? Alright. Look, this thing did not mess up one time last period. I'm going to start recording them. And now it won't cooperate at all. Somebody in here. Alright, here's my next problem. Log 10. You're kind of checking your memory here. Alright? What's the base if I don't tell you? It's 10. If I don't write it down, it's understood to be a 10. Alright? Anytime I don't write it and I use LOG, it's understood to be a 10. I don't have to write it when it's a base 10. Okay? I don't have to write it when it's base 10. What is log base 10 of 10? Very good. 10 to the first power is 10. Okay, here's example 2A. Okay? These are going to say, use the calculator. Round to 3 decimal places. Okay, are you ready? Alright, do this one. Log base 10 of 10. I know, I'm just asking. Sometimes it's nice to do something on your calculator that you know what the answer is, right? And then you get it and you're like, whoa, I'm doing it right. Okay? Alright, what about this one? Log of 2.5. You press log 2.5.
Is there an easier way to get there?
Okay? Alright.
Math alpha.
Okay, what's y'all's answer? 0.398. 0.398. Did y'all get it? You got 0. You put the same exact thing in? Anybody else? Are y'all okay?
I know, but hers still goes for 3.398. You know something. Something's going on in gosh dang it. Oh, I got it. I reset my calculator.
Here's what the kids last period, they did this. Take your calculator and go to mode.
And you change it to radians.
No, don't change your radians. We're not doing radians and stuff. Go to mode on your calculator. Okay? What the second line where it says floating 0, 1, and 2. What are they making it round off to? 0 decimal places. So it's what it's doing is it's taking your .037 or 370 or whatever it was, and it's rounding it off to 3 decimal places. So you just go right here, guys. For you? All right. Yeah, it'll round for you. That's where that came up, because I was showing them how to make it round for you if you couldn't round, because I told them I was going to count off if you couldn't round properly. And so then they all took every calculator and did that. They all sent them out to make it round up to 0 decimal places. Okay? All right. Here's the next one. C. All right. So fix your calculator if it's not fixed. All right. C is, dadgum, I don't know. I wonder if it's when I record, if that's what messes it up.
Probably.
I'm going to. Hey, see, press the mouse button and see if it disconnected. Shrink that down. Yep, it disconnected. Okay, thanks, John. All right. So C is log -2.
Where's the actual logarithm? Sorry, where's the actual logarithm?
LOG, right over there.
Right under the square.
X squared.
Oh.
All right, what'd y'all get? Error. You got error. So let's think about, why are we getting error? Look, what's the base on this thing? 10. So what power do I raise 10 to get a negative? Yeah. People, you can't raise a positive number to any power and get a negative. I don't care if it's a -2 or a -200. Okay? You can't do it. That's why it's telling you an error. We're not going to write error. We're going to write not possible. Okay? That's that asymptote thing. That's what it's doing over there. That's exactly right. Well, it can't do that. That's for sure. All right. Now, let's do this. 2 types of logs. 2 types of logs. You know what they are? Very good. There's a common log. What?
There was a dude on the other side of the wall. Like you said, there's 2 types of log, and a dude over there went, what?
A common log. A common log is the one that's on the calculator. It's this button right here. Okay? And it is only a base of 10. Alright? That's all it is. It's just a base of 10. I don't have to write it. The 10, it's understood. So if you see one and it doesn't have a base written there, then you can go, oh yeah, that's a base 10 log. Okay? The other one is called a natural log. Do y'all remember this from last year? Okay. This is the LN button on your calculator.
Gotta do it.
It didn't, I mean,
It's just 2 devices trying.
Oh no, that's crazy. Alright, the LN button, and the LN button is a base E. What does that mean? Euler's number, that's right. And you don't write the base. Okay? Anytime you see LN, you know it's a base E, or anytime they use an E, you know you need to write it with an LN. Okay? So, let's do this. Let's do properties of logs. Properties of logs. Okay? There are 4 properties of logs. We're going to do common logs and we're going to do natural logs because they're both the same thing, guys. Okay? So we're going to put the natural ones on the right. Maybe.
We can just do it Monday.
I need to finish this. The more time you have left on Monday, the more, of course y'all don't really need it, but the more you can work on your worksheet. Alright, so here's the natural one over here. Okay, so there's 4 properties. You know 2 of them already. Alright, one of them's kind of weird, and the other one you could guess. Alright, so here's the first one. It says log base A. That means it could be anything that you want it to be. Okay, log base A of 1. What is it? 0. Yeah. Log base A of 1 is 0. Why? Because, yeah, anything to the 0 power is 1. Alright, what's it going to look like over here? Over here it's going to look like ln of what? ln of what? 1. Very good. So it's going to be ln of 1 is equal to what? 0. And the reason is e to the 0 power is equal to 1. Alright, here's the second one. The second one is log base A of A. Log base A of A. 1. Okay? And the reason is because A to the first is equal to A. I know. I was too. I was getting a little bit frustrated. So over here, it's going to be ln of E. Very good, because that's a base E. ln of E is equal to 1 because E to the first is equal to E. Hard to think what's that going on. Alright, here's the weird one. You ready? Okay, so I'm going to tell you why. I'll show you why it's that way, and then I'll just tell you an easy way to remember it. Okay? Alright, so it's going to be log base A of A to the x. Now guys, look, this is what it's asking you. It's saying A to what power is equal to A to the x? Yeah. Okay? And then I remember it like this, because this is the crazy way to remember it. Okay? What's a logarithm?
Exponent.
What's the exponent? There you go. That's what I remember. Okay? And here's the other one. There's another one in this set, and it looks like this. A to the log base A of x is equal to x. Okay? That's the answer, right? Isn't that where that is? That's the answer. Here's what it would look like. If it said 7 raised to the log base 7 of 2, what would it be equal to? 2. Okay? Alright. Over here on the right-hand side, it's going to look like this. ln of e to the x is equal to what? X. And over here, it's going to look like e raised to the ln of x is equal to x.
Which way would you prefer, Best Friend?
Well, I mean, they're just different things. They're going to be given to you different ways. Like if you saw something and it said 3 raised to the ln, no, sorry, e raised to the ln of 6, it's equal to 6. Okay? Alright, here's the last one. You know this one. If log base A of x is equal to log base A of y, log base A of y, then what? Yeah, x is equal to y. Same thing. Alright, over here it's going to say if ln of x is equal to ln of y, then what else is going to be true? Yep, x is equal to y. Alright. No. Okay. So, let's do 2 more examples, and then, 2 more examples, and then we'll lack,
We just have a lot more.
we'll lack 3 more examples Monday, and they won't take very long, and then you can get started on your worksheet. Okay? Alright, so here's the first one. This is example 3. These are going to be use the property. Okay? Use the log property. It's the little things you forget to appreciate. Yeah, like something you don't have to put the pen up in 9,000 times in one class period.
I don't understand what putting the pen does.
I don't either. It just reconnects it for some reason, but I don't really know why. I don't understand why this class period.
Yeah,
Look,
the pen charge.
I taught 5th class.
Does it need new batteries?
It doesn't have batteries. It charges, and I keep it plugged in all the time.
Yeah, but how is that connected to the power source?
A piece of string. I'm pretty sure it's not the string. It's Bluetooth. That's part of the problem, I think.
But you don't charge it, you get Bluetooth then.
Huh?
She has a direct power source charger.
I got this right here is
I'm
charged.
talking about the pen. How do you
The
charge
pen
it?
charges when I put it in here.
There's
The little
nothing.
pen light. Sometimes
Well,
it
maybe
comes on and
if you've been
sometimes
using
it
it
doesn't.
all day, then it dies.
Well, it should. I don't know. We'll look at it later.
That's
All right.
That's why I
It's
put it in.
connecting.
That's why I
But
put it in.
it works your next class period though, doesn't it?
It didn't yesterday.
Yeah, I don't-
That might be what it is. Is it my battery? The battery's dying?
But it's just when
You've
you're
been using it all day
You've
though.
used it all day.
Well, that's what I told them. I thought it was it's worn out. I mean, I use it almost every day for 8 hours a day, and we've been doing this for how many years?
It's just like being on your phone all day. It's gonna
Yeah.
destroy your battery.
So, I don't know. Whatever.
Battery doesn't.
So, here we go. If I tell you that log base 2 of x is equal to log base 2 of 3, what do you know? Very good. Okay? This is what the properties will look like. What if I tell you...
I'm telling you, that's what it is. Because it completely disappears. The pen part.
Yeah, it does.
It's because the pen turns off.
But I don't know how to fix that.
You can't.
You can't use the charge.
You need a new
It
pen.
stays plugged in all night long.
That's why too. That's not good for a battery.
Get a new pen.
Well, it probably has an automatic
Wait,
cutoff.
they don't have
It
any.
has to charge. Like, if you just left the pin in the charger for a little bit.
Couldn't you just write with your finger on it?
No, it won't work. On that it will, but not on
During
that.
your lunch, you charge the pen.
I do. Whenever I'm not using it, I put it in here.
It's probably just ruined the battery.
So,
Overcharge.
that's probably why it works,
In the beginning of the day.
6th period is the period before this one, because it's charged.
Charges at lunch.
I guess so.
Does it work at the first period?
5th period it works. First period, no. And see, that's another thing. It doesn't work first period a
But it
lot.
charges all night.
Yeah, and it charges all night. Alright, so here we go. Thank y'all. I think y'all might have found the problem, though.
I think you just need
There's
to-
not anymore. They don't make with this stuff
They just
anymore.
need to buy a new one. Use it all.
Remember, we tried. We looked at that other thing, and we didn't like it. Because it didn't have an eraser on it. But it may be all I have, so. Alright, log base 4 of 4. What is it? 1. Come on, y'all. You gotta know these. Look, we just got 2 more, and then I promise we'll be finished. Log base 5 of 5 to the 7th. Very good. Alright, last one. 7 raised to the log base 7 of 14. Perfect. Okay? Well, 4 because I only did 1, but